All right, everyone. So we are going to move on and we are going to look at our genetics packet continuing here. And we are going to start working on our second type of problem that we have not yet looked at, which are found starting on page 7 in your genetics packet. So let's look, let's write down on our notes, just as we've been doing, page 7. All right. And today what we're going to be talking about are something called dihybrid crosses. And you've learned this year that the word di refers to two. So when we're talking about a dihybrid cross, we are talking about two traits being considered at the same time. All right. And so there's a little bit of more difficulty setting up these problems compared to the other problems that we looked at. And this is the most important part. For example, let's look in the middle of page 7. If we have a father that has the genotype D, D, A, A, and a mom that has the genotype big D, big A, little a, we would describe both of those parents as being heterozygous for two traits. One trait is represented by the letter D, and the other trait is represented by the letter A for both the mom and the dad. Let's write a little key off here to the side for ourselves so we can understand what these different letters represent. And so on the top of page 7 in your packet, we see that a big D means they have dimples. Two little d's would mean no dimples. A big A means you can roll your tongue. And two little a's would mean you cannot roll your tongue. All right. So now, what does this mean about the dad? The dad has the genotype big D, little d. He has at least one big D. So that means he is going to have dimples. He also has a big A and a little a. He has at least one big A, which means he can roll his tongue. And the same thing for the mom. So both the mom and the dad are heterozygous for two different traits, dimples, and the ability to roll your tongue. And we are going to draw a Punnett square to show the potential outcome of the offspring produced by these parents. Now we're going to draw a much bigger square than we ever have before. And the reason is because when we are considering a dihybrid Punnett square, we are not now looking at just one trait, but we are considering two traits at the same time. So we're going to draw a much bigger square. And instead of just having 4 individual boxes on the inside, we're actually going to have 4 columns. And we're going to have 4 rows. Okay? This is a 16 squares on the inside. And this is what you always draw when you're talking about doing a dihybrid. All right, so we're going to put the mom's gametes across the top and the dad's gametes kind of up and down the left-hand side here. Now, when we are doing this, we have to do something that we have not yet talked about, and this is called foiling. Foil. And I know you will learn this or should have learned this in math already. It stands for first, that's what the F stands for, outer, inner, and last. What it helps us do is to be able to figure out the different combinations of alleles that can be passed on from the parent to the offspring. And so in order to be able to fill out the top of our Punnett square up here to determine the gametes that the mom can give, we're going to look at what the mom has. And we're going to FOIL to determine the gametes. So we're going to use the FOIL. Here's how you do that. We're going to start with the letter D, big D. That is the first big D. What is the first of the second kind of letter? Big A. So we're going to write above the first box a big D and a big A. Then we're going to do the outermost letters in the mother's genotype, which happens to be a big D and a little a. Then we're going to do the innermost letters, all right, which happen to be a, little d, big A. Now, I just wrote the little d before the capital A. When you are doing a dihybrid, you want to always write, for example, if we're writing our D's first, you want to continue with that across the top, even though it is lowercase and the A is uppercase. All right, and then the last remaining of each kind would be the little d and the little a. We have written all the different possible combinations of D's and A's that the mom can possibly give in the eggs. We're going to do the same thing for the dad. All right. As a matter of fact, the dad has the exact same genotype as the mom, so it's going to be exactly the same. Big D, big A. That's the first of each kind of letter. Outer is going to be big D and little a. Inner is going to be little d and big A. And then the last remaining of each kind is going to be little d, little a. Okay, now we're going to combine them and neatly fill in our Punnett square. We're going to keep our D's together and our A's together. So we're going to write big D, big D, big A, big A. Big D, big D, big A, little a. We're always writing, if we have the option in this inner part, we're going to write the capital letter first. Next, we have big D from over here. And then the other kind of D that we're writing is up here, which is little d. And then two big A's. This one would be big D, big A, little a. Okay, the second row is going to be big D, big A, little a. Big D, little a, little a. Big D, big A, little a. Oops, broke my pencil. All right, let me show you how I'm getting this last one, just slowly, step by step again. Hopefully you've caught on. What am I going to write in this box right here? I'm looking for what are the two things that are kind of combining. I'm looking all the way over here. I've got a big D. I'm writing that down. I'm looking above. What's the other thing that is going to intersect when I come together in that box? It's going to be a little d. And I have two little a's. Okay, continuing on. Big D, big A, big A. Big D, big A, little a. Little D, big A, big A. Little D, big A, little a. Etc. Filling in the rest of the chart. Okay, then once your chart is filled in, then we take it and do it the exact same way we've been doing it. Okay, we're going to use that Punnett square. Now, whenever we're doing a dihybrid, we are not going to make a genotypic list because it takes forever to do. All right, we are usually mainly concerned about phenotypes. So let's make a phenotypic list based on what we have written out here. All right, so our phenotypic list remember what phenotype means. It means how this organism is actually going to look. All right, so what are our possibilities? Well, we can have offspring that have dimples, for sure, but we have to combine both of these different traits that we've been talking about into the same kind of phenotype. So dimples and being able to roll your tongue, that'd be one phenotype. We could also have people that have dimples and can't roll their tongue. All right. We can have no dimples, but you can roll your tongue. Or you could have no dimples and not be able to roll your tongue. All right, those are the different options we can have. So now we're going to go through and we are going to count how many out of these 16 boxes have dimples and can roll their tongue. Now we have to think about, what are we going to count? In order to have dimples, you have to have at least one big D. And I'm going to write a little blank there next to it because it could be big D, or it could be big D, little d. In order to roll your tongue, again, you have to have at least one big A, and then it could be big A, or big A, little a. All right. For dimples, again, here it's going to be a big D. Couple options for the second one there. Not rolling your tongue, the only thing you can have are two little A's. No dimples would be two little D's. And then again, to roll your tongue, you'd have a big A and a possible second one. And then no dimples would be two little D's, and not being able to roll your tongue would be two little A's. So that's kind of what we're looking for. Let me try and separate this a little bit so we can see what we're looking at here. All right. So dimples and rolling your tongue. We're looking for anything that has a big D and has a big A. So we're looking back at our Punnett square that we made, and I'm looking for anything that has at least one big D and one big A. And I'm going to circle it. One big D at least and one big A. One big D, and it also has one big A. That one has at least one of each capital letter. This one has at least one of each capital letter. This one I'm not going to circle. It has a big D, but there's no big A, so that wouldn't count. This one has at least one big D and one big A. This one does not. This one does. This one does. This one does not. This one does not. This one does. And none of the rest do. So now I'm going to count up how many boxes did I circle. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 16. So now I'm going to go down to my little list and I'm going to write down the fraction. 9 out of 16 would be considered having dimples and being able to roll their tongues. The next one I'm looking for is dimples and not being able to roll your tongue. So they have to have at least one big D, but they have to have two little A's. And I can't count anybody I've already counted. So let's go back up to the top and let's look. They have to have at least one big D and two little A's. I'm going to make this in a zigzag pattern. There's one. There's one. And there's one. So that's 3. So now I'm going to write down on my list, I'm going to say at least 3 out of 16 are going to have dimples and not be able to roll their tongue. And now I'm looking for no dimples and being able to roll your tongue. So they have to have two little D's and then at least one big A. I'm not counting anybody I've already counted. All right. So I have to have two little D's and at least one big A. I'm going to put some speckles on it. That's this one. And this one. And this one. 3. I'll go down to my list and I'm going to write 3 out of 16. And then the one that is left would be this one down in the bottom right-hand corner. And that's 1 out of 16. All right. And that is going to be the phenotypic expression of if you crossed both of these parents. Okay. Now, what does that mean? It means that these are the fractions. These are the probabilities of having a child with these certain characteristics every single time a child is born. All right. And so this 9 to 3 to 3 to 1 ratio is what you would always expect every time. I'm going to write it on the bottom. This is an important thing for you to remember. Every time two parents that are each heterozygous for two different traits are crossed, that means mated, you expect a 9 to 3 to 3 to 1 phenotypic ratio. Phenotypic. Okay, so that's always what you would expect, and that's exactly what we got. And that is how you do a dihybrid. All right, the most important part of this is being able to FOIL. Now, I could spend a lot of time going through some of the things we went through yesterday, such as writing out the decimal and the probability and the ratio, but you do those the exact same way that we did before. The only difference is we are typically not writing out a genotypic huge long list. We're trying to keep it a little bit more simplistic and just go with the phenotypic list when we are going through these problems that have so many different characteristics. All right, good. Now let's go on and do one other type of problem today. Let's look on page 8. Okay, one last thing. And I want to show you a much faster way of doing the problem that we just did. All right. Instead of doing a large Punnett square, when you are considering two traits, you can do two individual Punnett squares and combine. All right. So let me show you what that means. You're going to love this. We're going to draw two small, normal, monohybrid looking Punnett squares. All right. And we're going to use the same genotype we had in the last problem. We had a parent that was big D, big A, little a, times big D, big A, little a. Okay, the dimples and the being able to roll your tongue from our last problem. All we're going to do is we're going to split apart, and we're going to do one Punnett square for the D's, and we're going to do the other Punnett square for the A's. So what are the possible D's that we're going to combine? Let's write the moms across the top. Big D, and the dad's D's are big D, little d. And we're going to do the same thing with the A's. And we're going to fill out our Punnett square. Voila. All right. So now if you're looking on page 8 of your problem packet, you will see it's going to ask us to figure out the likelihood, the probability of getting these different types of colors of plants or showing up. But if we were doing with our dimples and our being able to roll your tongue, it's the same thing. So let's write down again the probability of getting dimples and being able to roll your tongue. Remember, that has to have at least one big D. And let me check what we had over here. Being able to, what did we say? Being able to roll your tongue is recessive. So that would be two little A's, correct? Oh, no, I'm sorry. That would be a big A. All right, being able to roll your tongue is also dominant. All right, so big A. Okay, so dimples and rolling your tongue, we said was that. We could also have the ability to be dimples and not roll the tongue. And we said that would be big D and then two little A's. All right, we said you could have no dimples and roll the tongue. That would be two little D's like that. Or you could have no dimples and not be able to roll your tongue. And that would be two little D's and two little A's. Now, that's what we came up with as our possible different phenotypes. Let's see if we get the same answers we did when we worked out that really long Punnett square on the other side. All right. How we're going to do that is, again, we're going to look at the probability. So what's the likelihood of getting dimples? All right, dimples have to have at least one big D. If I'm looking at this Punnett square, how many of those boxes have at least one big D? I'm going to write down 0.75 because 3 out of 4 have that. So to have dimples is 0.75. How about having at least one big A to roll your tongue? Yes, roll tongue. We see that 3 boxes also have that. All right. And if we are looking at what is the likelihood of being able to roll your tongue and be able to have dimples in this example, well, that's not hard to do. We can use math instead of having a huge, huge Punnett square in order to do that. All we have to do is multiply these two numbers together. So you take 0.75 times 0.75. All right. And if we are looking at what's the likelihood of being able to have dimples and rolling your tongue, and we put into a calculator and we say 0.75 times 0.75, oops, 0.75 times 0.75, we are going to get about 56% likelihood of having that. If we're looking at what's the likelihood of getting dimples, we already know that's 0.75. And what's the ability to not roll your tongue? How many of these boxes have 2 little A's? Only 1. So that would be that one. So 0.75 times 0.25, that would be about 19%. And then if we look at the ability to not have dimples, that's 0.25. And the ability to roll your tongue is 0.75. That would also be about 19%. And then the ability to have no dimples would be 0.25 and 0.25. And if we multiply 0.25 times 0.25, we are going to get 0.06, or 6%, about 6%. All right. And now all of these numbers that we just wrote down, they should add up to very close to 100. So if we do 6 plus 19 plus 19 plus 56, I get 100. All right. And that gives us 100% of the different alleles that can be present as far as this particular cross. All right. So now you learned how to do a dihybrid, a 2-trait, the long method and the short method. Great job, guys.